record.
Yeah. I was doing this in my mind to choose. Yeah, because I was gonna
Okay. This is your freebie today. Wednesday we'll review. So Wednesday we'll do multiple choice questions and problems and all that.
That's what I'm like, see, I didn't watch it.
I get 18.
Okay,
I got 18. Did you get in?
Yes, it did. Come on to the pair. I explained to the ASMR was.
You didn't want, that must be because you were studying. Watch it, right? For this test.
Everybody was. Yes. I didn't want to see it.
Okay, so to name alcohol. So you remember I told you that we had AN, EN, and YN, and that the ending was an E. Give me a color, any color. Okay, so we had ANE, ENE, and YNE were our endings, right? But really, these are the endings. Just the E. These are going to be part of every name that we do. A, E, or I. Okay? The E is going to change for alcohols to OL. Alcohol. OL. That's where it's coming from. Okay? So we're going to drop the E's and add OL. So does that mean you can have double bonds in alcohols? Yes. You have triple bonds in alcohols? Yes. Can you have all straight chain single bonds in alcohols? Yes. Okay. So we're going to have OL for our ending. The carbon, the OH is attached to, gets the lowest possible number. Okay. And you start at the end of your chain, just like before. The hydroxyl wins over any substituent. Okay, so this compound, you have 2 carbons. Okay, so you drop the E. My little line is sort of skewed. You drop the E and you add OL. Ethane would be it if it didn't have an alcohol on it, right? Now, why isn't a number 1 used? Why don't we say 1 ethanol? Can you have 2 ethanol? No, because it would just be that one over, right? It's always ethanol. So methanol and ethanol don't get numbers, and that's pretty typical of a lot of functional. Okay, now look at this one. You'll notice that we're going to name it 3-hexanol. We're going to start counting at the right side. 1, 2, 3, 4, 5, 6. Why don't we count from the left side? It would be a 4. You want it to have the lowest number. Okay, now just like with the double bonds and the triple bonds, you can put the number inside the base. Okay, so you will see things both ways. Okie dokie. Oh, wait. All right, so how do you name that one? What do you do first? Work the program. Find the longest chain. The longest chain must include the carbon that has the OH on it, right? All right, so did you find it? How many? 6. Okay, where do we start counting? Right or the left?
Right.
To the right. Yeah, it's right. It's right from the right. Okay, so what is the name? 4,5-dimethyl 1-hexanol. Oops. Oh, there we go. Is that not going away? All right, we'll just do that. I just need it. Okay, how about the one there on the right? What do you think? So what is the longest chain? 3. Does everybody see it's 3? Okay, it's not 5. Okay, these are the 3 carbons. Okay, which way do you want to number? Left to right or right to left? Right to left. Why? OH wins. Okay, isn't that nice? It kind of really helps life that OH wins. Uh-oh. We'll get there. Yeah, this one isn't going away either. Something must be goofed up on them. Okay, so 3-fluoro-1-propanol. You could say 3-fluoropropan, 1-ol. Anybody want me to write it that way?
No.
Okay. You just don't like it, do you?
Not
All right, how about the bottom one? This one here. Okay, how many? 8. Okay. Remember, every bend and every end is a carbon. If it's not a carbon, the element is written there. Okay, which way did you want to count? Right to left. All right, so what are you getting? 7-methyl, 3-octanol. Yeah, none of them are working like they're supposed to. Okay, how about the last one?
3,3-dimethyl.
Yep, that sounds good. Okay, you find the longest chain. Notice you're going to number from the right because the alcohol gets the lowest number. Okay. What if it's on a ring?
Cyclo.
Yep. You see a ring, you got it right? Cyclo. All right. So what do you think the base name is for that compound? The first one up there. Cyclo who? Yep. That's an A right there, even though it's not looking like it. All right, so how do you want to number that thing? Which carbon on the ring is going to be number 1? The one with the OH. Okay, so do you remember from double bonds the rules of the numbering of the ring? You want to get the lowest what? Possible numbers, okay? Now, with the double bond, those 2 carbons had to be 1 and 2. Okay, we only have an alcohol, so that's just going to be 1. So which way do you want to go? Clockwise or counterclockwise? Clockwise. Everybody see that? 2 will be next. If we went the other way around, it wouldn't come till 3. All right, so what is the whole name of that? 2-ethyl, 4-methyl, cyclopentanol. Okay, that one worked. Okay, now I want you to notice what's not in there. A 1. Same rule as with the double bonds, okay? The carbon with the hydroxyl is always number 1, so the number is not written in the name. Okay, remember to go for lowest numbering first. What if the numbering is the same? Then what do you do? Like one way you get 1, 3, 5. The other way you get 1, 3, 5. How do you know which way to go? What was the rule? alphabetical. But you only do that if the numbering is the same. All right, so look at that one up there and tell me the name of that one. What's your base name? Remember, we're kind of working backwards. Cyclohexanol. And I think it makes it easier because now you know what carbon is number 1. Okay, so you always know that, and that kind of like has simplified your life, believe it or not. Okay, now, which way do you want to go? Clockwise or counterclockwise? Counter, because this is going to be number 2. Who can tell me what that is? Nope. Isopropyl. Okay, so it's 2 isopropyl cyclohexanol. Remember, no 1. Good, okay. Kind of little review of some of the rules too. Okay, here you go. Let's see if you remember all these rules. I got 18, right? One more. There we go. Okay. So, what is the longest chain? 7. Okay. So I'm going to go. Let me get a pen. 1, 2, 3, 4, 5.
Down for more.
6, 7, or 6, 7. Why do we go down? What was the rule? Most substituents. Good. Okay. So the name is going to be okay, 5-ethyl, 6-methyl, 2-heptanol. Okay. See why it's not A. Okay. At least nobody picked B. All right, what if you have an alcohol and an alkene or an alkyne in the compound? Okay, the alcohol has higher priority, so the chain gets numbered so that it gets the lower number. Your ending is going to be enol or inol, obviously depending on whether or not you have a double bond or a triple bond, right? Okay. If you have a straight chain compound, you will need a number for both. So you will have to put a number in the base name. Okay, so here, let me do one that's really simple. What will be the name of that one? It's going to be how many carbons? 6? 5. Okay, so it's going to be pent. Okay, and then we're going to have ene, and then we're going to have our alcohol number. So the number for the double bond will go in the front. Oh, I didn't give myself very much room because I can't write over here. See? It's one of the most irritating things. All right, so what's the number for the alcohol? 1. What's the number for the double bond? What? 4. So that will be 4-pentene-1-ol. If you want to write it the other way, it would be pent-4-ene-1-ol. Okay. It's just like you put the number of the first carbon in the double bond, just like you did before. Now, in cyclos, the alcohol is always number 1, so you're not going to put that number in. Okay? So if you have this compound, okay, how would you name that? That's connected to this carbon right there. Okay. Here's your clue. Wasn't that nice? Okay. So what else do we need? Hex, because it has how many carbons in the ring? 6. Okay, and then what do we need? What do we put here? En. Okay. And then the OL. You don't have to put a 1 for the OL because it's automatically 1. So what goes in front? 3. Okay, so it makes sense. Okay. 1, 2, 3. 1, 2, 3. I think after that I don't know any other languages to count to 3. All right, so how would you name that first one up there? Ooh. I mean, like, work the program. So what's the longest chain? Now, the longest chain has to include what now? The carbon of the OH and your double or triple bond. Okay? Usually it's pretty obvious. All right, so what is it? How many carbons? 5, right? Right? Okay, how do you want a number? Right to left or left to right? Right to left, because the alcohol is going to be number 2. All right, so what are you getting for the name? Is that what you said? Okay. That's what I said. All right, all right. Usually we say ein. So. But that's okay. You just have to write it down. You don't have to say it. We're not going to have an oral. Or you have to use the words. Now you just have to write it. All right. What do you think about the next one? What do you think about that one? Well, what's your base going to be? Okay, cyclohexanol, what's the question? Which way do you number it? Do you want to go counterclockwise or clockwise? It's probably counterclockwise. Ooh, that's a 4. What is this? Isopropyl. Hopefully we review that today. Remember, no 1 for the alcohol. No 1 for the, it's assumed. All right, what do you think about this one? Not much? What's your longest chain gonna be? Yeah, you have to include the triple bond. So it's going to be 1, 2, 3, 4, 5, 6, 7. Don't forget to count the carbon at the end too. I've noticed people skip that. And don't skip a carbon on the zigzag part. Okay, that's not a good thing. All right, so what is your base name going to be? Hept, ein, Y-N, and then 1 OL. Now you put the 1 on the chain. Okay? The only time you don't use the 1 is in the rings. Okay? All right, now what is this little thing? propyl. So the whole thing is going to be 5 propyl, 6 heptine, 1 OL. Oops. Okay. Remember with triple bonds also, you don't have cis or trans. We don't say cis or trans in the rings unless you get to really big ones, because in order for the ring to close, they all have to be cis. Okay, remember that? And if you had to say cis or trans, you put it all the way at the front of it, just like we did before. Okay, give the IUPAC name for the compound below. Make it yes. Your thing ain't working? Oh, but it finally got it? Okay, good. Yeah, because this is 19 now. Okay. All right. So we're going to go 1, 2, 3, 4, 5, 6, 7. Okay, so it's going to be 5, 6 dimethyl, 6 heptene, 2 all. Okay, that would be D. Okie dokie. All right, are we good? Okay, what if you have more than one alcohol? Because yes, they all. All right, so you're going to use diol. Okay, you need 2 numbers to tell where the hydroxyl groups are located. You put those 2 numbers in the base name and use the E. You can put them in the front of the base name. Okay, so like this one, you're going to go 1, 2, 3. So it's going to be propane diol. Okay, and your numbers are going to be 1, 2. Notice that we're putting the number in because it could have 1, 2, or you could have 1, 3, right? Or 1, 1, or 2, 2. No, we won't get there yet. Okay. Here it is putting the numbers in the base name, but you can do it the other way too. Oh, let me write. And I want to show you this. See that E is there? I think it's there for English reasons, so that the A will be a long vowel. Because if you have vowel, consonant, vowel, the vowels, right? If you had A-N-D-I-O-L, you would say propandiol. Okay, they don't want that. They want you to say propane diol. Okay, that's how come I think they put those E's in there sometimes. Okay, it's awkward at best. Okay, all right, so look at this compound up here, the second one. What do you think about that one? What's just a group? Yes, this is going to be a group on your chain. Okay, how do you make a ring a group? Cyclo.
Or hexyl.
Hexyl, yep. All right, so what's your base name going to be, though? Butanediol, okay. And which way do you want to number, left to right or right?
Now, do you count, is it 4 or 5? Do you count this carbon?
Okay, do you see what I circled? This carbon is in the ring. It's not in the chain. Okay, see how we circled that? Okay, so how many carbons do I have up here? 1, 2, 3, 4. So everybody see, like you might literally have to circle it so that you don't count too many. Okay. All right, so which way do we want to number? We want the lowest possible numbering, so it's going to be this way, right? Left to right. So our base name is going to be butane 1,3-diol or 1,3-butanediol. And then you have your cyclohexyl group on carbon number 1. Okie dokie. Okay, you can have it the other way. It's butane, A-N-E-D-I-O-L. I can't even read it. Okay, what do you think you named that last one? What's your base name going to be? What? Cyclopentane, and then what? And then diol. What do you think the numbers are going to be? Okay, you need one more thing. Trans. Everybody pick up on that. You need to have trans cyclopentane 1,2-diol or trans 1,2-cyclopropane, or sorry, cyclopentane diol. You can have it though. Okay, so make sure that you pick up on when they're showing you. Is it going to do it? Okay, trans. Okay, remember the cis and the trans go all the way in the front. They're typically in italics. You'll notice that in books and stuff. I'm not going to make y'all write in italics. We're not. I just want you to write it. Okay, any questions on those? All right, so name this compound. So what's your base name going to be? What is it? Okay, and then what do we need after the octane? Okay, which way are you numbering? Good. Okay, so what do we got there? 6-methyl. Okay. So you could have 6-methyl 3,5-octane diol or 6-methyl octane 3,5 diol. Remember that when you have di, tri, etc., you have to have the corresponding number of numbers to go with it. So even in the ring, when we had cyclopentane diol, you had to have 2 numbers to go with that. Okay, so keep that in mind. Okay, phenols. This is compound here is called phenol. And it is named with phenol as the base name. It is a benzene ring with an OH directly attached. Okay, so anyone who's going, why isn't it benzenol? Okay, I don't know. Somebody named it phenol. Yeah, a long time ago. Now, if you look at the second compound over here, you'll see that, find a pen. I'm going to circle phenol in this compound. See that? Okay, so you have to be able to pick that out. Okay, that, oh, that's a phenol. Don't be trying to do cyclohexatriene. Okay, we don't do that. Okay, now what carbon do you think is number 1 though? The one with the OH. So do you want to go clockwise or counterclockwise? Clockwise. Okay, so it's going to be 2,3 diethyl phenol. And again, we're not going to put the 1 in. Okay, now you see the next compound over there on the right? Okay, circle the phenol in it. Find it. It's right here. There's your phenol. And then what do we have on here? A chlorine. That is referred to as a fluoro, right? Everyone remember that? Bromo, chloro, fluoro, iodo. Okay. Our dog is named Odo. Somebody said, isn't that too close to no? Don't name your dog Odo because it's too close to no. I said, well, problem was we got him at 10 months old and his name was O-T-O-E. No idea where that came from. So we did a slight switch and made it O-D-O, which is the old Star Trek. There's a character named Odo. Star Trek. That's where it came from. Okay, rather than trying to totally change it. He had a lot of, he's kind of was like a recipe. Yeah. Like we had to feed him food out of our hand in order to get him to come to us. Like he would not come by people and stuff. Okay, so now this would be 3-chlorophenol. But when there are only 2 substituents on a benzene ring, you can use this other system. Ortho, meta, and para. Have you seen that yet in lab? Like looking stuff up, or I don't know exactly what all you've done. So, all right. So, if the group is next on the carbon next to the OH, it doesn't matter if it's a double or a single bond. We're going to talk about that later. But that is ortho. It goes at the front of the name, and you would say orthochlorophenol. Okay, and it would be ortho-chlorophenol, or you would use O-chlorophenol. If it is 1 carbon away, like this one, that one is meta. There's your meta. Meta-chlorophenol. You can write M-E-T-A, or you can just write the little m. And it is a little m, not a capital M. Okay? And the last one is para. And you'll notice that para, they're 2 carbons apart. There's para. Now you can use the numbers, or you can use ortho, meta, or para. Okay? We don't put them together. Like we wouldn't say 4-chloroparaffenol, okay, or 4-para. You use one or the other. And you can only use ortho, meta, and para when there are only 2 substituents on the benzene ring. See this one down here? The first one that we named, you have to use numbers because there's more than 2 substituents. Otherwise, it's confusing. Okay? If you said orthoethyl and meta-ethyl, I don't know, ortho-meta-diethyl, it's like, well, you could have it one up here and one down here. Okay, so it's confusing unless there's only two substituents. It's a really old system that's just been around forever, and the IUPAC just said, all right, we'll just go with it. I guess that's what they said. You can use numbers for all of it. You don't have to use OM and P, but you're going to see that we're going to talk that way, and I'm going to say we used parachlorophenol. Okay. Okay. So now, sometimes benzene rings can be substituents. Okay. So the benzene ring here is a substituent on your chain. Okay. When it's a substituent, because this starts coming up in this chapter, it's called a phenyl ring. It's not called a benzyl ring. That's something else. Okay, it's called a phenyl ring. So how would you name that compound? Where are we going to start counting? Where the OH is, right? So this is going to be 1, 2, 3, 4. So it's going to be 4-phenyl. What? Then what? 1-butanol. Okay. Now you can have 4-phenylbutanol. Okay, you can have either one. I'll write the other one too. So you guys have it. 4-phenyl, 1-butanol. Okay, this benzene ring as a substituent doesn't have any special preference for numbering. It's all alphabetical, just like the other rules. Okay. Okay, you'll notice that there's an OH in this compound and a benzene ring, but it is not named as a phenol. Why not? Because the OH is not on the benzene ring. Okay? Okay. Any questions? Are you with me? Okay, so phenyl is the new word. All right, so name that compound. And I will add using the IUPAC system. I don't want you picking E and say, but that's my name for it. No, I'll tell you. Still need something? Yeah. I think that's it. Yep, it's meta. How do you know it's meta? Because, okay, there's one carbon in between. Okay, the para would look like this. Okay. So far, so good? Okay. Okay. We classify alcohols by looking at the carbon the OH is attached to. If it has one R group, it's primary. If it has two, it's secondary. If it has three, it's tertiary. Can you have a quaternary alcohol?
No.
Why not? Okay. What kind of alcohol is that? Tertiary. Okay. So could we do this? What's wrong with that? The carbon has how many bonds? 5. Okay. All right. So let me draw you a compound, and then you're going to tell me what kind of alcohol is that? Primary, secondary, or tertiary is never going to be quaternary. Secondary. So you look at this carbon, it's got 2 other carbons and 1 hydrogen attached to it. So it's secondary. All right, you got it? You want one more?
Yeah.
Yeah, you a little nervous? What's that alcohol? Primary. Okay, you look at this carbon here. This is your R group attached to it. It doesn't matter what's attached to that or this, okay? Only matters what's directly attached to that carbon. This is really important because the kind alcohol is going to change its reactivity, okay? All right, so I want you to classify 2,3-dimethyl-butan-2-all. Is it primary, secondary, tertiary, quaternary, 0, or rebel alliance? We need a new Star Wars. You don't know anything about the Rebel Alliance, just don't pick. Am I missing somebody? It only says 18. There we go. We're in like Flynn, right? Okay, I'm going to draw the picture because that's how you decide. You got to draw the picture. Okay, so butan 2-all, how many carbons? 1, 2, 3, 4. On carbon number 2 is the alcohol, right?
Yes.
There we go. On carbon 2 and 3, we also have methyl. So 1 here and 1 here. So you look at the carbon that the OH is attached to. How many R groups does it have? 3. So it's, okay, so you have to draw the whole compound. Don't just draw the base name. Okay. Honest, I wasn't trying to be tricky. Okay, alcohols are generally soluble in polar solvents because they are polar, right? Okay, so you look at this compound. Okay, that's 1 butanol, right? Where is the polar part of that molecule? It's the what? The oxygen and the hydrogen. This is the most polar part. This part of the molecule is non-polar. But this part can hydrogen bond. Do we remember what that is? Okay, so you can hydrogen bond with water. It's where the O is attracted to the H. What kind of H's? Ones that are also attached to oxygens or nitrogens, remember? Okay, not just any H's. All right, the more hydroxyl groups, the more you've increased your solubility in water. So a compound like this is very soluble in water because it has 2 OHs on it. The smallest alcohols, methanol and ethanol, are infinitely soluble in water. That means they can be mixed in all proportions. Okay, so that's the thing with ethanol. Here's ethanol, the one that you can drink. If you're over 21 and you do so in moderation, don't drink. You got it? Okay. Nobody drank and drove yesterday, right? So I can't even say that. I sound drunk saying it. Okay, so here is our non-polar part, and here's our polar part. Okay, Notice that the nonpolar part is really small. There's a battle going on in the molecule between the nonpolar part and the polar part. The polar part says, I want to dissolve, I can hydrogen bond. The nonpolar part says, no, you can't do that. So until the nonpolar part gets big enough, this part will allow it to hydrogen bond. Methanol and ethanol, the nonpolar parts are really small. Okay, so we're infinitely soluble. So when they mix alcoholic drinks, they can put as much alcohol in as they want. It's not like Brita. Okay. Okay, to make alkoxide ions, which are RO minus Na plus. Okay, and the Na can be different things. It can be sodium or potassium or lithium. We use these as nice bases back in the last semester, right? To do elimination reactions. Okay. Hydrogen gas is emitted. You simply take the alcohol and you add sodium or potassium in there. Those are the two that are the easiest to make in the lab, and so they're the ones that get used the most. In particular, sodium is. You may all be going, oh, but sodium is so blendable with water. Yes, it is, but we use it all the time. Okay? We just don't throw it in water unless you have a little issue with the sink. All right, so you would take your alcohol and you would add sodium, and this is a redox reaction. Remember redox? Reduction is gain. Oxidation is loss. Oil rig, you remember the oil rig? And what are you gaining and losing? Electrons. Okay, that's it. We're not going to calculate them. All right, so here is, we're getting off hydrogen gas. Okay, that's why when sodium is put in water, it lights on fire, because it gets enough heat from the reaction that the hydrogen gas that's being formed lights up. Okay, that's where the flammability is coming from. Okay, if you ever want to, if you're goofing around on YouTube or whatever, go search sodium reactions, and you'll see all kinds of stuff with sodium and water. Like somebody recorded it, they threw it in the lake, okay, and they recorded it and all this. And you can see a lot of exciting kind of explosions. Okay, so doesn't matter what your R group is, you get the same thing. And it doesn't matter if you use potassium, you just get a potassium salt instead of the sodium salt. So typically what you would do is you make these and then you use them in your reactions. Okay, so you would make it in your little round bottom flask and then throw the next thing in. Okay, the other option is to add a stronger base, like sodium hydride. Okay, the H minus will pull off the H plus and make the sodium salt. That is not a redox reaction. Only the first one is redox. Okay? Okay, so Wednesday we'll review. We'll do some multiple choice and we'll answer questions. So if you have questions, read them. All right, y'all have good, you got lab today? Lab? Yeah, okay, I thought maybe.